8th grade, lesson 2b, division of numbers in exponential form. We already learned about multiplication of numbers in exponential form with the same base. This is kind of the same thing. We are dividing numbers with the same base and different exponents. The rule says I'm subtracting the numbers. Let's see how that works. Let's divide 2 to the 5th power by 2 to the 3rd power. Same base, different exponents. Let's rewrite it. Let's write it in standard or expanded form. We have 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times. I'm dividing it by 2 times 2 times 2. Now, if I simplify, just like I simplify fractions, I can simplify 2 and 2 and make 1. I can simplify 2 and 2 and make 1. And these 2 and 2 and make 1. What do I have left? I have 2 taken by itself 2 times, which means 2 to the 2nd power, with the denominator of 1, which I'm not going to write. So what does it mean? I'm going to take 2 to the 5th and divide by 2 to the 3rd, and I will have 2 to the power of 5 minus 3, which is 2 to the 2nd power. That's pretty much all you need to know. When we multiply the exponents with the same base and different exponents, we add the exponents. When we divide numbers with the same base and different exponents, we subtract the exponents. That's all it is. So I have 7 to the 9th divided by 7 to the 6th. That makes it 7 to the power of 9 minus 6, which is 7 to the 3rd power. 8 fifths to the 9th divided by 8 fifths to the 2nd makes it 8 fifths to the power of 9 minus 2, which is 8 to the 5th to the 7th power. Negative 5 to the 16th divided by negative 5 to the 7th makes it negative 5 to the power 16 minus 7, and that is negative 5 to the 9th power. 13 to the 5th divided by 13 to the 4th makes it 13 to the 5 minus 4, and that is 13 to the 1st power, which is just 13 because 13 taken by itself only once is itself. Exercise 5. Now we are working with variables, but it's exact same thing. A over b to the 9th divided by a over b to the 2nd makes it a over b to the power of 9 minus 2, which is a over b to the 7th power. Okay. Exercise 6. Let x be a non-zero number. What is the following number? So we already tried that actually before. We have x to the 5th minus 4th power, and that is x to the 1st or just x. Can the following expressions be written in simpler form? Let's go ahead and simplify them. We have 2 to the 7th over 4 to the 2nd is 2 to the 7th divided by 2 to the 4th. How did I get 2 to the 4th here? Because I broke down 4 into 2 2's. This is 2 to the 2nd, and because I have 2 of these, that makes it twice as much, and that's why it's 2 to the 4th. The first step is done for you, so you have 2 to the power 7 minus 4, and that is 2 to the 3rd power. Okay, exercise 8. They broke down the 27 into 3 to the 3rd power, and that made it 3 to the power of 23 minus 3, and that is 3 to the 20th power. This one is different because here I have 3 to the 5th times 2 to the 8th, 3 to the 2nd times 2 to the 3rd, over the same fraction. I can actually break it down into 2 separate ones, and you will see that I'm dividing numbers with the same base and different exponents. So I will get 3 to the power of 5 minus 2 multiplied by, this is big multiplication sign right here, and I'm working on this one, 2 to the power of 8 minus 3. And that will be 3 to the power of 3 times 2 to the 5th power. Okay? Same thing here. Negative 2 to the 7th over negative 2 to the 5th times 95 to the 5th over 95 to the 4th. So we are dividing numbers with the same bases and different exponents. And here I have the same base, different exponent. So I will get negative 2 to the power of 7 minus 5 times 95 to the power of 5 minus 4. I will get negative 2 to the second power times 95 to the first power, or just itself 95. Make sure to have parentheses over a negative number. Exercise 11, and last one here. We have to simplify these expressions. One thing that can be confusing, you can say that, well, this one is not written over as a fraction. I cannot simplify that. Well, now it is. We can write it over 1. So what I will have here is 5 times x to the 3rd multiplied by 3 times x to the 8th over 1. I can see that I can simplify these x to the 8th and x to the 3 because they have the same base but different exponents. And using my rule of quotient, I can actually do that. And I can multiply 5 times 3. That is basic multiplication. So I will have 15 x to the power of 8 minus 3. I don't have to worry about this one because it doesn't really mean anything. So I will get 15x to the 5th. Let's look at this one. 5 over x to the 3rd multiplied by negative 4x to the 6th. If you want to put it over 1, go for it. Now I see x to the 6th and x to the 3rd, and I can multiply 5 and negative 4. 5 times negative 4 will give me negative 20, and I can write x, because it's the same base, x stays the same, and I'm just subtracting the exponents. 6 minus 3. I don't have to worry about the 1, and I have negative 20 to the power of x to the power of 3. Last one. 5 over x to the 3rd multiplied by 11x to the 4th over 1 if you want it. I can see the two bases which are the same and different exponents, and I can multiply the constants here. So I can have 55 x to the power of 4 minus 3. Since I'm dividing, I'm subtracting the exponents, makes it 55x to the first power, or just written by itself. Okay, now it is your turn to do homework. That is your problem set for today. I will see you in class.